Hello guys, in concept 1310 you will learn how to simplify expressions with negative exponents. So all of this top stuff here you've learned in concepts 1300A and 1300B, so you don't need to write anything down for this portion that I've circled. So let's go straight to looking at our property of negative exponents. Okay, so the property, it says it is a term with a negative exponent can be written as a reciprocal. So go ahead and write this down. Reciprocal of the term with a positive exponent, and we'll get to some examples of what this means here in a second. But let's kind of refresh our memory on what a reciprocal means. So for example, if you have the number 2 and you're asked to write the reciprocal of number 2, remember that any number, any whole number can be written as a fraction by just making it over 1. So 2 is the same as just writing it as 2 over 1. The reciprocal of 2 or 2 over 1 just means flipping it around. So what's on the numerator becomes on the denominator, and what's on the denominator moves up to the numerator. So 2 over 1, if you flip it, 1 over 2, that is called its reciprocal. Okay? All right, so let's go ahead and work out some problems that deal with negative exponents. So in math, we don't ever want to leave answers in negative exponents. So our goal is to always write exponents write terms in positive exponents. In these examples, we are going to look at how we can get rid of negative exponents. In math, we do not want to leave answers ever in negative exponents. Okay, so letter A here, we have the term 3 to the negative 3, and that's a no-no in math. So how can we get rid of this negative exponent that we have? So again, remember, any number can be written as a fraction by making it over 1. So the rule says, if you want to get rid of an exponent, you just move it. If it's on the numerator, it moves to the denominator, or if it's on the denominator, you move it to the numerator. So if I want to get rid of this negative 3, I'm going to flip it around, so the 1 will go on the top now, and then that 3 will go on the bottom, and then instead of to the negative 3, it will become to the positive 3. So you always flip it around, and then you drop that negative exponent. It just becomes a positive, okay? And since this is just a number, we can actually go ahead and evaluate it and get an actual answer. So I have 1 over 3 to the third means it's 3 times 3 times 3, right? So 3 times 3 is 9, 9 times 3, 27. So here you get 1 over 27 as your final answer. B. So looking at B, we have negative 3, x to the negative 2, y. Okay, so again, I see that I have a negative exponent. I cannot leave answers like that. So I'm going to go ahead and make this over 1, right? And I'm going to start to move things around to where I don't have any negatives or any negative exponents anymore. The negative 3 is not raised to a negative number, right? This is really just negative 3 to the first. So negative 3 will stay where it is on the top. The x to the negative second, so x is what's raised to the negative 2. That's something we cannot have, so I'm going to go ahead and move this from the top to the bottom, so from numerator to the denominator, and I'm going to go ahead and drop the negative sign. So it used to be on the top, now it's going to go on the bottom. I can do that as long as I drop the negative sign, so instead of x to the negative 2, it will be x to the positive 2, x to the second. The y here is raised to the first power. That's a positive number. That's good to go, so I'll leave it where it is. So now my final answer here would be a negative 3y over x squared. Let's look at C. C, we have 1 over 2m to the negative 2. Okay, so it's already in a fraction. I'm running out of room, so I'm just going to write it here. It's already in a fraction form. 1 is good to go, so that stays where it is. Notice how you have 2m to the negative 2. The only thing that's raised to the negative is the m. So the 2 is really raised to the first. So the 2 stays where it is on the denominator. The m is raised to the negative 2. I cannot leave it that way, so I'm going to move it from the bottom to the top. I'm going to move it from the bottom to the top, and then I'm going to go ahead and drop that negative exponent. It will just become positive. So m to the negative 2 used to be on the denominator. Now it's going to move to the numerator. And then instead of to the negative 2, we will be just to the positive 2. Now I have 1m squared over 2. Well, you don't really need to write a coefficient of 1. That's not really the simplified version. So I would just go ahead and write my final answer as as m squared over 2. Okay? Okay, so let's look at some examples. We have 9 examples here that will help us dig deeper into how to work with negative exponents. Actually, in these problems, we're going to combine everything we've learned so far about exponents. So we're going to combine concept 1300A, 1300B, and 1310, all kind of in one practice. So let's look at problem 1. Problem 1 has 7x to the 0, y to the negative 2 over 14. Okay, so 7 and 14, that's a fraction, right? 7 over 14. If you were to reduce it, you could go ahead and reduce it by 7. So the numerator becomes a 1. 7 divided by 7 is 1. Denominator will become a 2 because 14 divided by 7 is 2. So now I have a 1 here and I have a 2 here. X is 0. So if you go back to 1300B, you learned about 0 exponents. Remember, anytime you have a term raised to the 0, it always becomes a 1. So x to the 0 is just 1, right? And then you have y to the negative 2. We cannot leave our answers in negative exponents. So once again, if it's on the numerator, I can go ahead and move it to the denominator and then I can just go ahead and remove that negative 2 to a positive 2. So now what I end up with is just a 1 on the numerator, and then on the denominator I'm going to have 2y squared. 2y squared. Okay, and that will be my final answer for number 1. Number 2, I have 3ab to the 0. The 3 and the a are just raised to the first, right? When you don't have an exponent, it means they're raised to the 1 power. So 3 to the first is just 3. A to the first is just a. B to the 0 is 1. Anything raised to 0 is always going to be 1. So b to the 0 will be 1. I can simplify this a little bit by timesing the 3 with the 1, right? So 3 times 1 is 3. So it's 3 and then a. That will be your final answer there. Number 3. Number 3, you have negative 4 in parentheses raised to the negative 2. So what I'm going to go ahead and do is make this over 1, right? And I did this so that I can get rid of this negative exponents by just finding the reciprocal of this. So I'm going to flip it around. So I have negative 4 to the negative 2 on the numerator. Now it's going to move to the denominator. So it's negative 4 parentheses to the positive 2. And then the 1 that used to be on the denominator will move to the numerator. I just flipped it around and dropped the negative sign. I can actually go ahead and evaluate this and find an actual answer. 1 is just 1. Negative 4 squared, like when it's in parentheses like that, it means it's a negative 4 times another negative 4. And as you guys know, a negative times a negative is positive, so negative 4 squared would be 1 over 16. Or negative 4 squared is 16, so the final answer is 1 over 16. Number 4, you have negative 2, b to the negative 3, and c. Okay, so I know what I cannot really have is this b to the negative 3. That's kind of the issue with this one. So I know I'm going to have to move it to the denominator. Because of that, I'm going to go ahead and make this over 1, and I'm going to start to flip things around. Negative 2 is not raised to a negative or anything, so that stays. B to the negative 3, I can move it to the denominator and then drop that negative sign, so it's b to the positive 3. And then c is just really raised to the first, nothing wrong with that, so I'll just leave it where it is, and that will be my final answer. Negative 2c over b to the third power. Number 5. I have 5a to the negative 1, b to the negative 2 over a to the negative 4. Okay? So I can move some things around, right? At this point, you know the 5 stays where it is. I'm going to do the numerator first before I move anything from the denominator. So I have a 5. That a to the negative 1 will be moved to the denominator, so now it's a to the first. This b to the negative 2 will also be moved, so it's b to the positive 2 on the denominator. This one here, a to the negative 4, it's on the denominator now. I can shift it up, move it up to the top, to the numerator, and drop the negative sign. So as you can see, I just moved things around, and now I don't have any negative exponents. However, we know from concept 1300A that if you have exponents with the same base, you can go ahead and you're dividing them, you can go ahead and actually take care of those by just subtracting the exponents, right? So this one is actually going to just move to the top by doing a to the 4 minus that 1, right? So you have 5 a to the 4th minus the 1, because this one, when you have the same base, you can go ahead and subtract their exponents, 4 minus 1, right? And then that b to the second stays where it is. So here your final answer will be 5. A to the 4 minus 1 is 3 over b to the second. And that will be your final answer. Number 6. As you guys can see here, we have some negative exponents, and we don't really have a fraction, but I'm going to go ahead and make this into a fraction by making it over 1. And then I'm going to start shifting things around. You have a negative 3 to the negative 2, right? So I'm going to move that to the denominator, so it's a negative 3 to the positive 2, right? M to the 0. Anything raised to the 0 gives you a 1, so this here is just a 1. N to the negative 2, I can move it to the denominator by just making it positive, so it's n to the positive 2. This one on the denominator, if you want to, you can carry it over and make it like times 1. You don't really need to do that because anything times 1 doesn't change your final answer. Let me simplify this problem a little bit. Numerator has a 1. Negative 3 to the second power. Notice here, unlike number 3, where it was in parentheses, notice how negative 3 is not in parentheses. So leave that negative sign, right? So really, it's just 3 that's being squared. So 3 times 3 is 9. So I had to carry that negative sign over because not everything was in parentheses. Not the negative 3 was raised to the second. Only the 3 was. So you had to carry over that negative sign. And then n to the second. So your final answer here will be 1 over negative 9n squared. Okay? And if you wanted to, you could put the negative sign right in front of your fraction. That's fine too. Okay? Number 7. I can see that I have a negative exponent that I need to move, so I'm going to go ahead and make this into a fraction. So the negative 3 is fine where it is because that's not raised to a negative, so negative 3 stays. What I need to move is the x to the negative 5, right? That is where the negative 5 is happening. So I'm going to just shift it to the bottom. So x to the negative 5 used to be on the numerator. I'm going to now move it to the denominator and just drop that negative sign, so it's x to the 5th. Negative 3 over x to the 5th is your final answer here. Number 8. On number 8, we're going to do one thing at a time. I'm going to take care of the numerator and then move on to the denominator, okay? First, however, notice how you have a fraction, right? You have a 2 over 12. So treat it just like you would have done in middle school. If you had a 2 over 12 and you were asked to reduce that, you can reduce both sides by 2. This becomes a 1. 2 divided by 2 is 1. 12 will become a 6 because 12 divided by 2 is 6. So now, a 1, and this is a 6. So you have a 1, because 2 got reduced. U to the 0, anything to the 0 is a 1. V to the third is fine for now. Denominator, that 12 became a 6, because I reduced it right here. V to the negative 2 will be moved up. And then it's positive now. Okay, so at this point, I have 1 times v to the third times v to the second, and everything is over 6. So again, going back to 13a, when you are multiplying exponents with the same base, you go ahead and add your exponents. So I'm going to go ahead and do that. So I have 1 times 1, which is 1. I don't really need to see a coefficient of 1, so this is gone. So v, 3 plus 2 is 5 over 6. And that will be my final answer for this one. Number 9, you have negative 5 to the negative 3. I know I cannot have a negative exponent, so I'm going to make this into a fraction by making it over 1. And I'm going to have to do its reciprocal. So move the 1 that's on the denominator to be on the numerator now. This negative 5 to the negative 3 that used to be on the numerator, it's going to move to the denominator. So it's negative 5. Instead of to the negative 3, it will be to the positive 3, like that. Okay? I can go ahead and simplify this some more because it's just a number, right? So I have 1 over negative 5 to the third means you have a negative sign, and then it's 5 3 times. It's 5 times 5 times 5. So my final answer here will be 1 over, you carry that negative sign, 5 times 5 is 25, times 5 is 125. So your final answer here is 1 over negative 125. You can also put the negative right in front of the fraction sign. That's completely fine. Okay, this takes care of 1310. So now go ahead and do your teacher talk. It's actually an essential teacher talk. So 1310 essential teacher talk before you can go on to Math Excel and then take your quiz once you're finished. All right, thank you guys.